Today we're going to start chapter 4, which is all about quadratics, and today we're going to look at their graphs and how we graph quadratic functions in standard form. And this is section 4.2, pages 202 through 206. So first off, a few key terms. A quadratic function is when your greatest exponent is 2. So it's typically written ax squared plus bx plus c. Ax squared is the quadratic term. That's what makes it a quadratic since you have the x squared. Bx is the linear term, and then c is your constant. And we know that the graph of a quadratic is called a parabola. So one way to graph a parabola is simply by making a table of values. You pick some x values that are part of the domain, plug them in, and find your y values, and then plot the points. So I'm going to quickly go through. I've already worked these out for us just to save us some time. I typically pick a few negative x values, so I would pick probably x is -2, -1, 0, 1, and 2 to start with, and then go from there. If I need to find more, I can do that later. And this just gives me an idea of what's happening when x is negative, at 0, and when x is positive. So I plug in these numbers. So I plug in 3 times -2 squared minus 12 times -2 plus 6. So I'm plugging in the x value into both of those places where I see an x, and then I'm working it out to get my output, and this would give me a value of 42. If I continue, if I do 3 times -1 squared minus 12 times -1 plus 6 and work that out, I get a value of 21. If I do 3 times 0 squared minus 12 times 0 plus 6, I get a value of 6. When I plug in 1, I get a value of -3. When I plug in 2, I get a value of -6. And so since a few of these first few values are so high, I think I might keep going just a little bit to get a few more points. That way I have a good idea of what the graph should look like. So if I plug in 3 times 3 squared minus 12 times 3 plus 6, and work that out, that gives me a value of -3. And then if I go one more, plug in x equals 4, 3 times 4 squared minus 12 times 4 plus 6 gives me a value of 6. Now it's just a matter of plotting these points. So 0 is 6, that's my y-intercept. Then I have 1, -3. Then I have the point, sorry, went the wrong way there. +1, -3. Completely graphed that one wrong. So make sure you fix that. 2, -6, so 2 right, 6 down. Then 3, -3. And then 4, 6. And so notice you should see some symmetry. Parabolas are symmetric, and that's what we're going to talk about today. It's helpful when you know the symmetry of a quadratic. That speeds up the graphing. So this is kind of a last resort. We're going to learn some new techniques that make graphing quadratics easier versus having to pick points and plug them in and do all this work to find all of these values. Just real quick while we're here, the domain of every quadratic, in fact, is all real numbers. So that's -infinity to +infinity. The range this quadratic, the lowest y value we go down to is this vertex down here, which was -6, and then we increase forever to +infinity. Alright, so as I mentioned, quadratics are symmetrical, and so if we can find the axis of symmetry, which is a line that will always go through the vertex, is very important. So the vertex is either the lowest or the highest point if this were turned upside down. And the axis of symmetry will always go through the vertex. If we can find that axis of symmetry and find a point on the left side of the parabola, then we know we have that same point equal distance from the axis of symmetry on the right side. A couple other key features that are important and easy to find. Number one is the y-intercept. We know every y-intercept has an x value of 0. So if we're plugging 0 into ax squared plus bx plus c. If I plug in 0 to the quadratic term and 0 into the linear term, they're just going to go to 0. So our y-intercept is always going to be the point 0, c. So that's an important point that will be easy for us to plot. And then if we know the axis of symmetry, then we also know a point that's equal distance from the y-intercept across the axis of symmetry. So the axis of symmetry, this is a very important equation that you need to know. X equals negative b divided by 2 times a. And that again comes from the standard form. The b comes from the linear term. The a comes from the quadratic term. Again, the lowest point or the highest point is called the vertex, and then we'll do some more practice in a little bit with domain and range. Here's just a quick picture so you can see what the difference between maximum and minimum looks like. If your a is positive, your parabola is going to open upward, and so you're going to have a minimum value down here at your vertex. If your a is negative, so if you have a negative x squared or a negative number, and so like negative 2x squared, your parabola will open downward, and so you have a maximum at your vertex. If you are asked to find the max or min value, the max or min value is always the y coordinate. Okay, x is where it happens. The value of the maximum or minimum is the y value. All right, so let's look at this graph. F of x, or y, equals x squared plus 4x minus 3. And rather than having to make a full table of values, let's look at some key points that are quick and easy to graph. The first we're going to look at is our y-intercept. Again, we know that x is always 0, so if I plug in 0 squared plus 4 times 0, that's going to go to 0, and so 0 minus 3 is just negative 3. That's a very easy point to find very quickly and very easy for us to plot. So we've got 1 point on our quadratic. The next thing, if we could find the axis of symmetry, that's going to help us out a lot. And so the axis of symmetry, I usually abbreviate A of S, is x equals negative b divided by 2 times a. Again, it's ax squared plus bx plus c is your standard form. And so b, in this example, is 4. I need the opposite of b. So that's going to be negative 4 divided by 2 times a, which in this example is 1. And so that's negative 4 divided by 2, which is negative 2. That means I have a vertical line. My axis of symmetry is at x equals negative 2. There we go. And what this also helps me find very nicely, notice that the y-intercept is 2 units to the right of the axis of symmetry. And so to keep things symmetrical, I have to have the same point equal distance to the left. And so now I have a second point very quickly, very easily on my graph. The other thing that's very easy to find from using standard form in the axis of symmetry is the vertex. We know that the vertex will always occur on the axis of symmetry, and so I know that every point on this line, on this axis of symmetry, the x value is always going to be equal to negative 2. So I already have half of my vertex. I'm going to find the y value of this by inputting my x value into the equation. So negative 2 squared plus 4 times negative 2 minus 3. That's going to give me 4 minus 8 minus 3, which is a negative 7. So that gives me a vertex of the point negative 2, negative 7. So 2 left, 5, 6, 7 down. And there's a very general, good, rough sketch of what my parabola would look like. And notice instead of having to make that full table and find all those values, I really only had to plug in the number one time. Just real quick for practice, the domain, again, of every quadratic is all real numbers, so that's from negative infinity to positive infinity. And the range of this quadratic, the lowest point, the lowest value is negative 7. That's my minimum value is negative 7. And then this points upward forever, so we go to positive infinity. All right, one more quick example we're going to look at very quickly using the axis of symmetry. Again, also in the y-intercept as well. So I'm going to go ahead and plot the y-intercept. That's the point 0, 3. Again, x is always 0, and then the c. So that's a nice, easy, quick point. Now if I find my axis of symmetry, that's x equals negative b divided by 2 times a. Again, very important. that you learned that equation. So x is equal to the opposite of b, so that's going to make it -2 divided by 2 times -1. So -2 divided by -2 gives me a +1. So I have a vertical line, my axis of symmetry, at x equals 1. And that also automatically gives me a second point because of the symmetry. The y-intercept is 1 unit to the left, so I know I have that same point equal distance to the right of the axis of symmetry. What this also does is gives me half of my vertex. The x value of my vertex is 1. To find the y value of my vertex, I simply plug in 1 into the equation in place of x. So -1 squared plus 2 times 1 plus 3. That gives me a -1 plus 2 plus 3, which works out to be 4. And so my vertex is at the point 1, 4. And so notice this graph, this parabola, opens downward. So a couple of things I want to look at real quick. Determine whether it has a maximum or a minimum value. This is the highest point, so we have a maximum value of 4. Again, if we're talking about the value, it is the y value of the vertex. And then again, just for practice, need to be comfortable with giving the domain. The domain of every quadratic is all real numbers, so -infinity to +infinity, and we could plug in any x value we want to. However, the picture helps us here with the range. The lowest this will ever go is on and on forever, so -infinity. But the highest that this graph goes up to is that maximum value of 4. So again, using standard form allows us to use the equation for the axis of symmetry and the y-intercept to get just a few quick, easy points to plot, and then it's much, much easier rather than having to graph using a table for everything like we did on this very first example. Table is great. If you forget, if all else fails, you can always fall back on a table, but using the axis of symmetry, your vertex, and your y-intercept is a much quicker option for graphing quadratics in standard form.